Hey kiddos, welcome back to our discussion of chemical reactions, one of, I think, the most fun units that we're covering so far this year. And we're going to zero in on how do we know whether or not an ionic substance is soluble or not. Now, we do get some clues when we're dealing with a balanced equation if it's written out in words. Because if the words give us the words like solution, then we know that it's a soluble substance because solution is another word for homogeneous mixture. Now, what we want to look at here are some rules for ionics so we know whether or not we want to put in our balanced equation, whether or not we want to put an aqueous after this chemical symbol or a solid after the chemical symbol. And you do not have to memorize these rules. You just have to be able to interpret them. So we've divided them into two broad categories, groups that are soluble. In other words, they'd have an AQ, but might be, and in this case there are, some exceptions. Well, an exception to soluble is insoluble. So our exceptions would be solid. And if you memorize just a couple of easy ones, you don't even have to look up on this table. So some of the most basic ones, therefore, would be our group 1. All group 1 salts are soluble, and there are no exceptions. There's not a single anion that can make it insoluble. So sodium chloride, sodium nitrate, sodium acetate, sodium carbonate, sodium phosphate, sodium oxalate, sodium dichromate, every one of those are soluble without exception. And we could say the same thing for potassium. So if it's a salt, an ionic compound that has a group 1 cation, it's going to have an AQ after its symbol. The same would be true for our ammonium salts. So ammonium sulfate, ammonium nitrate, chlorate, perchlorate, it doesn't matter. They are all soluble. There are no exceptions. Every one of them would have an AQ. Now, when we get to some of the halogens, there are some exceptions. So the general rule is that all chloride, bromide, iodide salts are soluble. So for example, if I had calcium iodide, that's soluble. But if I had, and I'd put an AQ after it, so I'd write calcium AQ. Now, if I had silver iodide, that's under the exception list. And so that would have a solid after it because it would be an exception to the soluble rule. Now, and the same thing we could say for our sulfates and our fluorides. So if I have aluminum sulfate, so aluminum sulfate would fall under, and hopefully you're getting a review of how to write chemical formulas. Aluminum sulfate would fall under the soluble, and therefore we'd put an AQ, but strontium sulfate is an exception. So an exception to the soluble rule is insoluble. All right. Now, the other rules fall under, they're generally insoluble, but we can't break the rules we just learned. So all salts of hydroxide are insoluble. Insoluble, remember, means does not dissolve. And so we would put a solid after it. And our exceptions for hydroxide are going to be group 1 ammonium, and then barium, strontium, and calcium ion. So barium hydroxide, since it's an exception, most hydroxides are not soluble, but since it's an exception to that, it would be aqueous. All right, so hopefully you can interpret that table. And I've got a little activity available for us, and we will be working on those as we go. We'll be using this information. So until the next video, this is, as always, signing off.